In this question, we are given that tan 58 equals to m. Let me write it here. We are given that tan 58 degrees equals to m. They expect you to know that any term is over 1, right? They will never show you over 1. And you can agree, ladies and gents, that from SOHCAHTOA, we are given TOA. Right? We are given TOA, which means the m is the opposite, the 1 is the adjacent, on our right angle triangle. And we can see that on our right angle triangle is going to be in the first quadrant. And this angle here will be 58. And this angle will be 90. The opposite of 58 would be m. And then the adjacent would be 1. Right? And then doing the theorem of Pythagoras to get the hypotenuse, we are going to do, I'll call it r. I'll call the hypotenuse r. So we're going to have r is equals to square root of 1 squared plus m squared, which is just equals to square root of 1 plus m squared. Right? So our hypotenuse is square root of 1 plus m squared. Right, remember when we do Pythagoras and we're looking for the hypotenuse, you must add. Perfect. Now, what will be the value of this angle here? We know that the total angles in a triangle is 180. So I'm going to say 180 minus 90 minus 58. And that gives me 32. That gives me 32 degrees. Okay? Now, ladies and gents, let's go on. Going to do this now. Let's see. Okay, now we can answer the questions. We're looking for 5.1.1. 5.1.1. They want us to determine the value of sine 58. Sine 58. We know that sine 58 is opposite over hypotenuse. Looking straight at our triangle, the opposite side is m. The opposite of 58 is m over the hypotenuse, which is 1 plus m squared, all under the square root. And that is our final answer. All right. Now, ladies and gentlemen, let's come to find sine 296. Okay, 5.1.2. They want us to determine sine 296. And sine 296 is way big. We need to reduce it first. So to reduce this, I can see that 296, I'm going to use 360 minus, let's see. It's going to be 360 minus 296. So we're going to minus 64 degrees. And this is in the fourth quadrant because 360 is here and minus is here. So in the fourth quadrant, so it's going to be negative sine 64 degrees. And sine 64 degrees, we do not have it on the triangle. But the nice thing is we have 32, which is a double of 64. I mean, which is, when we times by 2, we get 64. Which means here I can represent this as negative sine 2 multiplied by 32. Because I saw 32 on my diagram. So 64 is 2 times 32. 2 times 32 is 64. The next thing now is I have sine 2 theta. So the negative is still there, and we have sine 2 theta. Sine 2 theta is 2 sine theta cos theta. It's a double angle identity. It's 2 sine theta cos theta. Now, ladies and gents, let's go and look at our diagram. What will be sine 32 and what will be cos 32? Okay, let's see. Sine 32, 32 is here, is going to be opposite over hypotenuse, which is 1 over So sine 32 will be 1 over square root of 1 plus m squared. Then cos 32 will be the adjacent, which is m, over square root of 1 plus m squared. Okay? And then multiplying the negative 2, the 1, and the m, we get negative 2m all over 1 plus m squared, because we're multiplying the same number under the root. If I have square root of a multiplied by square root of a, the answer is just a. Okay? And that marks the final answer. In this case, we have negative 2m plus 1 m squared. Ne? The last question, they want us to find cos 2 theta. Okay? So cos 2 degrees. Obviously, I do not have 2 degrees on my diagram, but I can see something very common. I'm going to represent the 2 degrees in terms of a special angle and the 58. Remember, cos 2, I can write it as cos, the special angle is 60 minus 58. 60 minus 58 is still 2, so I still have cos 2. And the next thing is 60 is a special angle. And then 58, we're going to use the right angle triangle. Make sure if you do not have either of the angles and you cannot represent it as a double angle, use compound angles. And on your compound angles, one of your angles must be a special angle and the other one must be on the diagram. Now expanding this, we get cos 60, cos 58, minus sine, it's going to be plus, it's opposite. If this is a minus, for cos it's plus. If it's a minus, it's plus. We can check on the formula sheet. So we have sine 60, sine 58. Okay? Cos 60 is a special angle, it will give you half. If you read cos 58 on your diagram, cos 58 on your diagram, it's 1 over square root of 1 plus m squared, plus sine 60, remember, is root 3 over 2, it's a special angle. Sine 58 is m over square root of 1 plus m squared. We can check. Sine 58, it's m over that. It's opposite over hypotenuse. Now let's simplify this, ladies and gents. We're going to have this times that, which gives us 1. We just need to show equal signs here. Equals to over 2 square root 1 plus m squared. This one times that. Plus this one times that is going to be m root 3 or root 3m. But the m must be outside. Ne? Then this one times that one is 2 root 1 plus m squared. Right? Because the denominators are exactly the same, we can just add the numerators together over a single denominator. So we can write this under the common denominator because denominators are the same. Then here we have 1 plus m square root 3. And that marks the end of this video, ladies and gentlemen. If you found this helpful, please don't forget to share with family and friends and to subscribe to the SirGuru Academy YouTube channel. Thank you.